Welcome to our final video on factoring and our second video on factoring trinomials of quadratic form. When we factor in the last video, we talked about what happened where our first term in the quadratic trinomial was 1x squared, or whatever the variable happened to be. In this video, we will be discussing what happens when a is not 1, what happens when it is some other number. Now, with this, there are a number of steps because the way that we have to do this is to create for ourselves a factor by grouping problem rather than use a shortcut as we did in the last video. So we have to follow the technique that I showed you at the beginning of the last video. We have to multiply a times c. So in this example, we're going to do 5 times 12. 5 times 12 is 60. So we have to find two factors of 60 that will add or subtract to b, which in this case is 19. Factors of 60 are 1 and 60, 2 and 30, 3 and 20, 4 and 15. Okay, I get to stop here because 4 and 15 will make 19. Okay? I have to rewrite bx as an addition or subtraction problem. So I'm going to take 5n, and again, I know that I'm using x in the directions. That's because that's the standard form is written with x. 5n squared. To get a negative 19, I would need both of these to be negative, right? Negative 15 and negative 4 make negative 19. Negative 15n minus 4n and plus 12. Okay? Now I need to find the GCF of the first two terms. Factor by grouping. First two terms, last two terms. 5n squared and 15 both share, actually I'm going to split up the fraction bars. They both share 5 and n. And write it's n to the 1 because that's the lowest exponent I see. Divide. 5n times, and again you could do with the other GCF as well. I like to finish one group before I start another. 5 divided by 5 is 1. N squared divided by n is n. Minus 15 divided by 5 is 3. The two n's cancel. Close parentheses. The second set. Negative 4 and positive 12 both share a 4. And because I need that first term when I factor, when I divide, to be positive, I'm going to make this a negative 4 to switch the sign. Negative 4. Negative 4 divided by itself cancels. I'm left with n plus 12 divided by negative 4 is negative 3, and I certainly can leave that as minus 3. So I see 1n minus 3 in each parentheses. I've done this correctly. By the way, because we were doing this the long way, the technique that I showed you with factor by grouping does work. So I could say at the first step, did I split it up correctly? Well, is negative 15 minus 4 negative 19? Yes, I did that step correctly. Second step, did I factor, or I should say, did I divide correctly? Is 5n times n minus 3 5n squared minus 15n? Yes, I did that correctly. Is negative 4 times n minus 3 negative 4n plus 12? Yes, I did that correctly. So again, as long as you can go from the step you are at to the step you had before, you have done it correctly. Continue factoring. Take my two GCFs, 5n and minus 4. Drop them into their parentheses. The operation there is minus coming from the 4. And then the other parentheses is the repeated one, and minus 3 the remainder. And you could FOIL that when you're all done to see if it is in fact your final and correct answer. Right? You try this one. So hit pause and then hit play when you've got a solution.
And the answer here is 7x plus 5 times x minus 2. So here I have a times c, 7 times 10 is 70. Factors of 70 that get me negative 9 are 5 and 14. Because the 9 is negative, I have to do the difference of 14 and 5. The 14 is the larger number, so it has to have the same sign as 9, so the 14 is the negative one. Negative 14 plus 5 is negative 9. And then check. Negative 14 plus 5 is negative 9. I've done that step correctly. The greatest common factor of the first two is 7x. Dividing, I get 7x times x minus 2. If I multiply that out, I do get 7x squared minus 14x. I've done that correctly. The GCF of the second two is 5. If I divide that, I get 5 times x minus 2. If I multiply that back, I get 5x minus 10, so I've done that correctly. Take my two GCFs, 7x and 5, put them together, and then take my two remainders, x minus 2, put them together, and that is my final answer. I can multiply it out if I wanted to make sure that it is correct. And one thing I want to say before we look at our last problem that you may have noticed, when I do my a times c, or when I'm doing the find the factor of c that adds up to b from last video, I don't usually worry about the sign, like 7 times negative 10 should be negative 70, right? And the reason for that is I think it's easier to do that, factor the number, and then pick the factors if I just think about what do I need to do to get to that minus 9. Okay, 5 and 14 will get there using some type of subtraction, and then I figure out which one should be negative. So that's how I do it. You can look at a number of other videos, some textbooks, you'll find some different methods. So my way is by no means the only way. The last one here is this one. Now this one is a little bit different because, as you will notice, in the first two we did, a was what is called a prime number, right? 7 has only two factors, one in itself. 12 is a composite number. It has multiple factors besides one in itself. This makes the factoring process a little bit more involved, and this is part of the reason we have the technique we have. Some books will tell you a method that basically turns into guess and check. But if you use what I'm about to show you, what I have been showing you, you will not need to worry about that. Start the same way, a times c. 12 times 6 is 72. Factors of 72, 1 and 72, 2 and 36, 3 and 24. Again, we're looking for something that is going to get us to 17. 4, and that would be 18, close but not quite, not 5, 6 and 9, and then not 6 and 9, 6 and 12, not 7, 8 and 9, and that's the pair, the last one. We know that 8 plus 9 is 17, so that's how we're going to split up bx. 12x squared plus 9x plus 8x plus 6. Is 9x plus 8x 17x? Yes, I've done this correctly. Factor by grouping. The first two. 12 and 9, what do they share? Well, let's write it out. 12 has factors 1 and 12, 2 and 6, 3 and 4. 9 has factors 1 and 9, 3 and 3. 3 is the GCF. And they both share x. So we have 3x times 4. 12 divided by 3 is 4. X squared divided by x is x. Plus 9 divided by 3 is 3. X is canceled, close parentheses. 8 and 6, so let's see. Again, I know you can do this in your head. I'm just showing it on the screen to help you out. 1 and 8, 2 and 4, 1 and 6, 2 and 3, the GCF is 2. Divide by 2, they both don't have an x, so only the 8 does, so x is not part of the GCF. That 2 is positive. So then we have 8 divided by 2 is 4x, 6 divided by 2 is positive 3. Okay? Did I do this correctly? Well, is 3x times 4x plus 3 equal to 12x plus 9x? 12x squared plus 9x? Yes. I did that correctly. Is 2 times 4x plus 3 equal to 8x plus 6? Yes, I've done that correctly. I'm ready to make my final answer. Put my GCFs in a parentheses, 3x plus 2. And then I have 4x plus 3, my remainders. And notice that was a lot easier than trying to use the factors of 12 and 6 to try to guess and check where they would go. So, once again, using a process, using a formula, using steps, whatever you want to call it, is going to be the most efficient method to factor when a is not equal to 1. Thanks for watching this video and our overall series on factoring.